So let's get started with this true dimensionality. And if we load a certain dataset, iris for example, and this dataset has four features, so four columns, without a doubt, this dataset is four-dimensional. And we could also take a look at these two datasets again. And this dataset is described by two features, so it is two-dimensional. And this dataset is also described by using two features, meaning that it is two-dimensional as well. But you can see that something is different between these two datasets. And what is different is this true dimensionality. So you can see that this first dataset is really two-dimensional because we really need two axes in order to describe this dataset completely. Because if we just use a single line, we would describe the most of dataset variability, we would capture most of the information, but we wouldn't capture all of it. So we could say that this is a two-dimensional dataset in two-dimensional coordinate system, meaning this dataset has true dimensionality of 2. On the other side, when it comes to this dataset, we could use a straight line, one-dimensional coordinate system in order to completely describe all the variation, all the information from this data, and it would not make any difference. So we could say that the true dimensionality of this dataset is 1. And let's formalize this a bit. So we can say that each dataset consisting of n features can be represented by using minimum of p synthetical features, where p can take any value between n and 1, including n and 1. And in most cases, p will actually be equal to n, but not always. And we can also say that we can find multiple ways to represent variation in the data by using only p features. So we could again take a look at this two-dimensional data with true dimensionality of 2, and we could go on and, for example, rotate this data, and we would preserve all the patterns. Everything would remain the same, only the axis will get different meanings. And even though we preserve all the variation, all the patterns, as we have said, these axes have different meanings, but something else regarding this axis will be different as well. And this is the amount of correlation between these features that are denoted by our axis. And you can see that in this representation, there is a lot of correlation between these two features. You can easily predict what will happen with feature 2 by using feature 1. But there are some other representations of these patterns and variation in our data which yield features that are really not correlated. Because look at this. So this is the same data, the same thing represented in a different way. And you can clearly see that in this case, you can